With this analysis we want to do now, it is called Generalized Method of Moment. Now, this is the data set we want to use for that. In this one, we simply just label the data for independent variable. We have x1, x2, x3, x4, x5, x6, x7, while we have the dependent variable as y. We can actually give it different names, but that is how it is. Now, you can see that to prepare this type of data set, the names of the variables are at the top. Now, look at the first this thing here. It's firm name. That is column A, firm name. Here we use coil 1 up to how many kind of 4 or 5 places, and then we also use then there is period. Yeah, this data set, we are going to use it for GMM, and we're also going to use it for panel data also, because of the fact that it contains something that is very unique here, and that something is period and then the group. We are going to use it for panel data also later. So now, when you want to prepare your file for panel data analysis, make sure that there is a period there, and there's also there is time entity, and there's also there's time period there, and there's also an entity period there before all others, because these are the things that will be required to be entered there. However, we are not doing the panel now. What we want to do first is the generalized method of moments. Generalized method of moment. That's what we want to do. Now, for this, we now we call up the VSP. Call up the VSP. We call up the VSP, and then we go to this. That is we go to the research data. We look for the research data menu. We look for generalized method of moment. This is it here. We click OK, and we wait for the form. We wait for the form. Yeah, one thing about this is that for this version of VSP, the GMM is not yet required to have a form, but that will be done later. Where with this version of VSP, it is the console, that is the command prompt and console, that we are going to use. Now, this is what it has thrown up. Well, if you look at it, it said enter the number of independent variables or type C to cancel. Yeah, we are going to enter the number of independent variables here. I think that should be 7. We can use the entire 7, okay? And then it said again, enter name of the dependent variable or outcome variable. Then we have the name is y. That's what we saved it with here in that data set I just shown you now. Then it now said enter independent or predictor variable names separated by comma. Okay, that's exactly what we want to do now. So we have x1, x2, 2. You can see that I'm only separating them with comma. There's no space. X3, X4, X5, X5, X6, X7. Yeah, so we now click. You can see how it is. No space, but they are all separated with a comma. You can see it. You can see it. They are separated with comma, no space. Now we press enter. Yeah, and you can see how fast it is. Immediately you press enter, it has just brought out exactly what we have. Now let us now go back to the analysis and see what the GMM looks like. Yeah, so this is the GMM result. It starts with the display of the VSP logo. The VSP logo now takes you to the descriptive statistics, where all the variables are displayed, and then the count. There are about 40 observations. Then the mean for each, including even the dependent variable, also there. The standard deviation, the minimum value, 25%, that's the quartile. Then interquartile and the maximum value are also there. Then after this, we go to correlation matrix. You know, correlation matrix used to help to see whether there is a multicollinearity, incident, among the variables used, and where you have very high correlation, then know that such a thing happens. For instance, you have x2 to x1, x2 to x1, you have 0.46. Well, that's not too high, because they said it should be at least from 0.5 and upward. Then you know that there's a serious multicollinearity there. Well, there are some that have that. We have x5 to x7. You have 0.54, and so on and so forth. So that is that. Well, I think this is just an example. Now you can see the GMM data, what it calls itself IV-GMM estimation summary. Now, dependent variable is y. It could take any name, depending on what we give to it. Then we have r squared at 0.714. I just said r squared minus 0.1116, and so on and so forth. Then the estimator is IV-GMM. A number of observations is this, and then the covariance estimator is robust. It's robust, and then you now have other distribution. Here is a chi-square with degree of freedom 7, and then probability value that should be 0.6, which is very, very high, and that means not significant, using our 5% threshold. Now this is the parameter estimates. Intercept, the parameter is 92 point this. Then x1, look at its own, and so on and so forth. And then we now go to the standard error. You can see the standard error. So also you have to then the t statistics, and then we look at the p-values to see the one that is actually significant. The one that is significant here seems to be the intercept is significant as 0.03 is significant. Then also X3 is also no X3 is 0.9. I think that is just the intercept that is significant. Like I said, this is just an example data that was just fed just for the purpose of running this, so that the user, those who are viewing, will be able to know exactly how to prepare their data and how to enter the data and run it. So this is the following one is a GMM .py154 user warning. Figure converge average is non-interactive. Okay, that is just ordinary processing warning. Then after this, it now gives us our results, where it tells us where the results is saved. So it's saved to C value start GMM test.txt. So now that is where it is saved. Yeah, so that's the end of this one. Now that is for the screen. So if we want to know exactly whether what it is saying is a correct thing, we go to where it is what I think yeah, so yeah, so let's see. Yeah, that's it. That's GMM bar chart. I never even know that it was able to produce the bar chart. Now let's see the GMM bar chart, what it is. Yeah, no, this is a very funny bar chart. Well, I think this line chart or bar chart is called it. No, I think that's not what we are looking for. Let's look at the box plot. Okay, I think the box plot was a bit better. Okay, yeah, because of the values, you see some are so tiny while some are big, and indicating the positions of each of them. Yeah, so the line graph, I think, is going to follow the same pattern with the other one. You follow the same pattern. I think that's because the figures are so tiny. Okay, now let us look at this. Is the yeah, this is the GMM test. That is the one that is holding the results. So let's click it and see. Yeah, it's open. The VSP, statistical package, the IVGM, and then that's the results displayed. As the result displayed, parameter estimates IVGM. Now remember that why the IVGM, that is the GMM is done in the first place, is when when a researcher is not keen on doing pre-estimation tests, so it just goes on and do the GMM, and it is assumed that the GMM will take care of whatever is the fault in the data, which the pre-estimation will not be able to reveal. So that is about this, and I hope you have enjoyed watching the GMM show.